next speaker, Brandon Weaver, is, besides being a very snappy dresser, he's a Ruby lover and equally fond of puns, lemurs, music and art. And his talks always, maybe not the music part, they always bring together a bunch of those things, and it's a real treat actually. The first time I saw him speak was at RubyConf in the States, and it was a great treat. So I'm so excited that he's actually here. I was pretty stoked when I saw him in the lineup. I was like, oh, that's amazing, you're gonna love it. He is a Ruby infrastructure and frameworks engineer at Square, and he's traveled here from Oakland in California. And his talk, he'll share some tales from the Ruby Grimoire, and there'll be lemurs, and I like lemurs. So welcome, Brandon.
Lovely to be here. Yep, I had a little bit too much fun. Someone said something about wearing a tuxedo, but unfortunately it didn't get through customs, so you'll have to deal with this. We tried. Anyways, so who exactly am I? And this is a very fun book, by the way. Guess what it does? You see, I am an artist who eventually became a developer through a series of unfortunate mishaps. And how this happened is it started out with, you should try some web design. Okay, yeah, it'll make a little bit more money, make me a little bit more marketable. Well, how about you learn a little bit of JavaScript to put in there, animate it a bit? Okay, so I learned that. We're good. It's starting to get some clients. How about some backend? It went fairly far downhill after that, and as you can see, so far downhill that I ended up working as a Ruby engineer on frameworks and language architecture over at this place called Square, where I'm currently in charge of working with Ruby and a lot of other fun things over there. Feel free to ask me about that sometime afterwards, but that's not why we're here today. We're here for a story, and I do love a good story, and I brought one of my favorites today. So, shall we get started then? Our story begins. Our story begins with young Red and his master Scarlet. Now, you see, Red's studying diligently when his master Scarlet comes in. The Council of 3.0 has been called. I'll be gone for a bit to debate the merits of keyword arguments and deprecations, so be sure to study, because I'll make sure to have a special test when I get back just to make sure that you did. And with that, Scarlet departed. Now, Red is a mischievous little lemur. You can see him up there, checking out just to make sure that she's actually gone. And when he was sure she'd actually left, oh, he had some ideas. Some very special ideas, because you see, my esteemed audience, in the castle of Master Scarlet, there are secrets, forbidden corridors, libraries, knowledge untold and unseen for generations. And Red was going to find a few of those. So he went down and down into the depths of the castle, down the staircases, into the darkest of dark corridors. And there at the bottom he found it, a massive door wrought from steel locked tightly. A door he'd often dreamed about opening, and a secret only whispered in the halls of the castle. Great and terrible knowledges laid beyond that door, and perhaps even the secret to finally becoming a senior. And with that power, Red would become the master. And studying could be a thing of the past. Masters don't study, right? But the door, it opened at his touch as if inviting him in. Surely this was a sign of divine providence. So he entered, and in that hall he found a vast library, the likes of which were unmatched in the land of lemurs, dwarfing even the grandest city libraries of Master Violet. Knowledge beyond knowledge. And there at the center, he saw it. A book of legends, a grimoire of infinite power and possibilities, a dark manuscript rumored to contain horrors and wisdom beyond the capacity of a normal lemur. But Red was no ordinary lemur, so this was absolutely fine. So with the book in his hands, the knowledge would soon be his. So he took a moment to savor his triumph, and he opened the book. But the words on the page were strange. He couldn't understand a thing in there. Red was not going to be stopped like this. No, he had tricks for reading this type of thing. Not when he's this close. No. The knowledge would be his. But then something changed. The room slowly grew suffocating. The page, the words were fading into the paper, disappearing and running away from his sight. And the fog started to glow an angry red. And on the page, a new phrase came. Welcome to the Ruby Grimoire, and thank you for freeing me, young one. Freeing? What does it mean, freeing?
Behold the Dark Lord Crimson, the pages wrote out in reply, and Red looked up, and what he saw standing there, a spectre, malignant being cloaked in a swirling red fog, for the Dark Lord Crimson was free. And all Red could do was scream and scream and scream. Well, for a moment at least, until the fog coalesced. You see, I like whimsical, fun stories. This isn't very fun. This is kind of scary. So let's get back to fun and whimsical, shall we? Okay. Keep it down, keep it down. No need to be rude. I can't see a thing with that lamp. And it's been quite a while since I've had visitors here. Red stared back in a stupefied horror. Ah, the Grimoire, how long it's been since there was a lemur strong enough to open it. Sit down, welcome, so long indeed, a seeker of knowledge is at last, how exciting. What lessons shall we learn, what arts can we attempt, what stories can be told, so many possibilities indeed. Tales from the lands beyond the ripple into the deep shells, languages old and new alike, power beyond our wildest imaginations, all written upon these pages. But I must ask you, young one, are you willing to pay the price for that knowledge? And Red, poor Red, and started nodding vigorously, transfixed. There are knowledges here beyond him, and knowledges that would soon be his, no matter the cost. The true nature of the Grimoire. The Grimoire is a journal of my journeys into land beyond Ruby, where I met several wise ones beyond me, or anything that I'd ever seen before. And of all the tales that could be told, of all the languages and journeys, we shall start with 3, and perhaps some of my personal favorites. Tales of the Lemurs of Scala, of JavaScript and Haskell, each bearing knowledges beyond what I'd imagined. We'll take a glance at each today. The Lemurs of Scala. We shall first learn from the Lemurs of Scala. The Lemurs of Scala wear conical hats, spires to the heaven cloaked in robes that change color as often as they change their styles of programming. Where Ruby has flexibility, Scala has so much more. And the lessons we can learn from them give us insights into these flexibilities. They bring with them arts of closures and a spell known as a placeholder argument. You see, placeholder arguments are where an underscore can act as a shorthand for the arguments to a function. So, in this case, it might look something like this in Ruby. But what if we could learn how to use this placeholder style argument in Ruby as well? Now, before we can learn such tricks, we'll need to cover a few lessons first. And to start with, we'll need to know of closures. So consider a function which takes an argument A and returns a function which takes an argument B. The outer function here takes in a value A and returns a new function which takes in an argument B. Now, the interesting part about this is that A is currently visible in the return function, so the function remembers that value of A. And this is a closure in that it remembers the context of where it happened to be defined, or rather, it remembers whatever it can happen to see around it. So if we call this adds function with the value 1, we get back a new function that remembers that A was 1, which means when we call it with the value of 2, it returns back 3, remembering again that 1 from above. We can also provide this to a map function using ampersand, which is toProc in Ruby, which gives us back a list of 2, 3, and 4. But the nice thing is that we can also put this directly inline in the code as well and call it like this. Or if we're particularly naughty, we could also do this, but that's unreadable even for me. Please don't do that. So we'll prefer more explicit variants for now, but it's nice to know such things exist. But how does
that get us closer to placeholder arguments? Well, how does the plus operator in Ruby work? Let's take a look at that real quick. So how does Ruby know how to add two numbers? Well, as it turns out, there's a secret there. It's no more than a method call on a number or numerical. And it looks something like this if you squint hard enough and pretend C code is Ruby and leave out a few more details. Red stared with a little bit of a doubtful expression at this. What is a lesson, not an exact science? That's not the point. Anyways, moving on. With these two tricks, we know enough to make our own placeholder arguments. We just need a bit more Ruby magic. We'll be able to dance a fine Scala dance. So remember that integer class we'd mentioned? What if we made our own class, placeholder? We could call it parg because that's shorter and I don't like typing too much. We'll leave parg red as it acts just like the left side of addition here in a moment, and you'll see what I mean. Now, here's another fun trick. You can define operators on the singleton of a class. There's no rule against this, which means that we can do something a little bit like this. And oh my, the fun we can have with such a thing as this. So if we happen to do just that, we can use our lesson of closures to return a function because there's also no rule that says anything about returning a number from addition either. So using our lesson from closure, the function we return remembers the value a there, which was whatever happens to be on the right side of that addition. So we can do just that, which means we can do this. And remembering back to inline, that means we can put an ampersand in front of it, which will apply to proc after the plus method has already been called, because operator precedence in Ruby is very fun. Well, my definition of fun, perhaps. We'll ignore everyone else. Now, if we're particularly naughty lemurs, we can always redefine underscore as well. This, of course, can do bad things in REPLs, but we had to prove a point that it can be done. Now, imagine with me that we can write the rest of the possible operators. Use method missing, or maybe respond to. Ooh, so much more we could do here. We could even make it into something to say something like underscore plus 1 double equals 2 by making a stack builder. No, those are fun, but tales for another day. And another chapter in the Grimoire, perhaps later. Of dark magics. So Red stopped as they walked in. He had to ask, but aren't these dark magics? It feels like we're just doing bad things to language for the sake of doing bad things to language, aren't we? Some would say potentially, maybe, possibly, a little bit that this is dark magic, but I would simply say we're exploring the possibilities. We're having fun. I mean, you're having fun, right? I guess. Imagine the use of such a thing, how much more powerful Ruby could be with it. Should we not use it just because it happens to be a little bit sketchy? Red nodded, and they kept walking. The lemurs of JavaScript. Now, in my journeys in a land not far from here, I found the lemurs of JavaScript, fascinating masters with lessons even more fascinating indeed. The lemurs of JavaScript were fashionable masters with all forms of accessories, colors, designs, and decorations. Why, they even had a way to change the very language by which they communicated with using accessories in this most wonderful art called Babel. They bring with them an art of destructuring beyond that of which we know in Ruby. It allows them to pull values out of objects by their names. So let's say that we had a function to move north. And this function adds 1 to a y coordinate, not too much here, but it extracts x and the y values from an object passed to it in an art known in JavaScript as destructuring. But let's take a look at that. Inside of this function, the value of x is 1 and the value of y is 2. So we can use those values to add 1 to y and make it move north, if you will. Now, there is another magic in JavaScript you'll notice with the x there. And this is an art called punning, one I've not learned quite how to emulate yet, even though I do want to. And of course, we love punning in Ruby. Yes, several famous Rubyists love punning, but this type of punning is different and beyond us. It allows us to make a new object with x unchanged and y with 1 added, but that's an art for another day, namely after I figure out how to make it work. Anyways, we can do destructuring in Ruby, but first we must learn an art of extracting arguments from a proc, or a lambda, or a function, or a method. Now, let's say we had a function, fn. The name doesn't matter for now. Empty for now because we only want to look at its arguments. So there exists a method on proc, or functions known as parameters. And it returns back an array of pairs, the first item being the type of the parameter, and the second, the name. Now, if we were to map that, we could get the names of every argument to that function. Oh my, can we do things with this. Now, this is all we need to create a destructuring of our own. If we know the names of the arguments, that means we can use them. So let's say we have a point. It's a simple little struct, and for those not familiar with what a struct is, it's something like this, but I would much rather write this. So we'll keep that part. Now then, for simplicity's sake, we'll start with a point called the origin, which is an x of 0 and y of 0. And we'll make our own method called destructure, which takes in an object and a block function. We can assume for now that our object is the origin point, and our function has arguments of x and y. So the first step is to get the names of the argument from the block function we passed in, much like what we saw earlier. So if we had, for instance, a function which took in the arguments x and y being passed to this, well, that would mean that arguments end up becoming the symbols x and y. This allows us to get the argument names from any block function you could pass to this. Now, with those argument names, we can map over those names and use sin to extract the value from the object. We'll save those values in v's for now. Now, what exactly does that mean? Well, let's take a look. If we had our origin point at 0, 0, this means that we had our function with arguments of x and y, making this map statement effectively mean we're asking for object.x and object.y, or, in this case, 0 and 0. So both of which were extracted using the names of the arguments x and y. Now, what do we do with those values? We know where they are, we know what the names are, we know what their values are. What do we do with them? There's nothing to say we can't call the function sometime later with completely different values. In this case, we call the original function with those values after we pull them out of the object, which means this entire function ends up looking a little bit like this, where the function takes in a value x and y, and it is called with the values 0 and 0. So let's take a look back at our point and our origin. We can use destruction method on that point with the arguments x and y in our block function. And since this is 0 and 0, that means that x is equivalently equal to 0 and y is equal to 0 as well inside of that function. So given that, we can go inside this function and return back a new point that adds 1 to that value of y, which means we end up with a new function which returns back a point of 0 and 1. Now, see, look how much fun that is. Now, a clever lemur might be able to redefine methods using some of these same tricks, making a decorator or something like that that can tell the difference between an object and the actual expected arguments. But a chapter, again, for another day, I'm afraid is beyond us for the moment. Considerations. By this point, Red was worried, and he had to save something. I mean, this was absolutely unconscionable, wasn't it? But surely this is evil. Send is metaprogramming. Metaprogramming is the root of all evil in Ruby, isn't it? Oh, no, 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 no. Metaprogramming has its uses. A vast and seldom understood and explored territory. Naturally, there are dangers if so few understand it, but must one discard such power simply for such dangers, even if we don't entirely understand them? Perhaps, and perhaps not. It depends on the context and the wisdom of the wielder. And you, after all, are quite a wise wielder, aren't you, young Red? Evil is far, far too strong of a word, for it was merely misunderstood and abused by those not ready for it. Red nodded, considering himself obviously ready for such an art, and they moved on. The Lemurs of Haskell. Now I have one last lesson for you from the wise sages of the realms of Haskell. Descendant from their ivory towers, they bring knowledge far beyond even me, but knowledge is fascinating in their implications that shake the very foundation of the way we think about programming. They bring with them an art of lenses, an ability to focus on something and either see or change its value. Now, I cannot say I fully comprehend them, but I find them quite fascinating anyways. Now, lenses allow the Lemurs of Haskell to look deeply into a nested data structure and perform magics on those data without mutating them. This all sounds very odd, but we'll get to it in a moment. The examples they told me from the books of hackage were confusing at first, so I took some liberties in trying to make them understandable for myself. I cannot I really understand how make lenses work beyond that they fill in a lot of code that makes lenses work, but I may be able to explain the rest, so we'll leave that part alone for now. We have an atom and a point, with an atom containing a point, and we'll make lenses for both of them. And we create a function that moves an atom to the north that understands that new atom and presumably moves it north. Now, the point has an x and y coordinate, but what is that function doing exactly? Let's take a little bit of a closer look here. Now that's a little bit more simple. I like this form of Haskell. It's much easier to read. So, what it's doing is it's taking a point which has an x and y, and we're performing a function over that point, but more specifically the y, and something which looks like a lens. And we're doing this specifically over the y point. And over that y point, we happen to add 1, which gives us back a new point with 1 added to the y. So lens allows us to specify a path to something and run a function over them, or to get values out of that structure. Now, this is incredibly abstract. I didn't understand the value of it whatsoever, until Lemurs of Haskell reminded me that Ruby already has such a function, one I had not thought about or considered before, and that function name is dig, which is 1/2 of the idea of a lens known as get. So it allows us to dig and find a value that's deeply nested in a hash or an array, or even a mix of both. By the way, that's very fun. Try that sometime. Now, the thing to pay attention to here, though, is that path. You notice how it has A, B, and C there. That is how we know where to dig to find that value, but that is also specifying a path of what data exactly we're focusing on and doing things on. And that is the basis of what makes a lens. So if you wanted to try and apply such a thing to Ruby, it may be difficult, but we can come close. So for the sake of this exercise, we can assume that we have a set of hashes with nested A, B, and C with the values being from 1 to 5. We'll be using those to demonstrate. So we'll start with the idea of capturing a path in a class we call scope. See, it even sounds like lenses. We're making progress already. So we want to capture the paths to what we're looking for in our scope. So we save those paths in an instance variable. And then the first thing we need to do is to get the values. Now we can wrap our idea of dig in a function to do just this. Now this is using the idea again of closures we learned earlier. Now why exactly would we want to write it like this instead of just .get? Well, because that means that we can do something like this. And we can map all of those hashes and say, I want to get the ABC value from everything that happens to come through this. And it's much easier to work with our placeholder class. But setting a value is a little bit harder. That takes some more work. Which is great, because I found this magical little function on Lemur Go, so I didn't have to figure out how to implement it. You see, this is the idea of cloning an object to make sure we're not technically not actually mutating something if we don't want to. So this works wondrously.
I don't entirely know what it's doing, but it works, and that's good enough for me for now. So, moving on now. We start by wrapping it in a function which takes in either a value or a function to transform whatever value it happens to find in that path. And inside this function, it gets a little bit more complicated. We start off by cloning the collection. Now, the Lemurs of Haskell are very much not pleased with my interpretation of mutation-free code, but it works, so I don't pay them any mind. Now, to get the path, we need to set our new value, we have to have a lead-in, which is what are the keys leading up to that value, and what is the end value we're trying to get to. In this case, we have A, B, and C, so let's say it's the same here. So that would make the lead-in to our value A and B, and the target key C. Why couldn't we just dig down to the value? Well, it turns out to set a value, you have to be right above it. So ironically, to bury something, you need to dig down to get to it in the first place. So right above the path we're modifying, we have a target location. And this is where we're going to be modifying things. So when we use that lead-in, we have A and B, which puts us right above that value, which gives us back a hash containing C of 1. So the next thing we need to do is decide what value it is that we're setting. In the first case, if we're given a block function, we give that value to that function. Now, we could have dug that value out right above, and it would make it impossible to set it in these next steps. So let's say that we had a block function that added 1. We'd be calling it with our target value, which is the result of pulling it out of the target location by the target key. And we'd end up with 1 plus 1, which would give us back a new value of 2. Or let's say we didn't use a block, we could always give it a static value to set instead. And this is the important part. Whatever we get, we have to overwrite the value at that target location at that target key to point to what the new value is instead. Now, the Haskell lemurs were very put off with me for this, but again, it works. So good enough, wouldn't you say? So if we were to use it on a group of hashes, we could deeply set a value according to a path. Like let's say we add 1 to every single one of those C values, making it 2, 3, 4, 5, and 6. Now, imagine with me for a second the possibilities if we happen to use triple equals to traverse instead and find out if a key matched, or if we kept searching until it found the first path. Now, this could be very interesting indeed. Now, I can't say I've written too much more on the Lemurs of Haskell because I believe they don't like me for some reason. They quit talking to me years ago. Going beyond magic. Now, Red was fascinated by all the implications of Crimson's tales, the possibilities, and what else may lay in the grimoire. How many more tales are there? Oh, many, many, many more from tribes and societies far and wide beyond all things. From the curmudgeonly Java lemurs to the mystical Lisp lemurs, all the way to the orderly Python lemurs and beyond. These were but a few of many, many tales. And there's an entire universe out there, powers beyond imagination, and so many more chapters in Grimoire to learn from. Imagine the potential we could learn from all the lemurs out there, of all their tricks and all their magics. We would be absolutely unstoppable. And then there was a sharp snap and a crackle as the grimoire closed. Behind them, the magic disappearing. So Red slowly turned, and what he found behind him scared him far, far more than the Master Crimson ever had, because the Master Scarlet was back, and she was not amused. Red quickly turned, trying to get help from his new friend Crimson, just to find a sign stating good luck in a puff of dust where his new friend was, standing not even moments before. It seemed that Crimson was also a little bit afraid of Master Scarlet, and had wisely chosen to flee. Sit. We have much to talk about now, don't we, Red? Red broke into a nervous sweat. Proper magic. This is a dangerous book, Red, full of all forms of knowledge you might not be ready for or know how to use appropriately. Red made an intense study of his feat.
You must remember, Red, for all the languages out there, you must use Ruby as Ruby. Magic can be confusing and unwieldy, difficult to control, and hard to understand. But even given that, there are many lessons to be learned, wisdoms that may be applied to the highest level of Ruby. The language is always evolving, and we need people willing to experiment to drive its future. Consider the lessons of the placeholder argument. Such a thing now exists in Ruby 2.7 by the name of numbered arguments, and many, many more may soon follow as well. What may be magic today may very well be canon law tomorrow. And there are many more tales in this grimoire you found, and many more lessons I'm sure Crimson can teach you, under strict moderation, of course. But be cautious and be wise in pursuing such knowledge, Red. The cost is high for using magicks in the great weave of production that you may not entirely understand or be ready for. But the cost is higher to pretend they do not exist at all. Now, in the meantime, I do believe I have a test ready for you upstairs, so you best get back to studying before I get back up there. And with that, Red made a very compelling run for the staircase. Epilogue. Now, there behind Master Scarlet, Red hurried up the stairs in quite a bit of a panic. And once she was sure he had left, she grinned and called out into the darkness. So, the Dark Lord Crimson now, is it? Quite the title you've taken for yourself now, haven't you, dear brother? Oh, I thought you'd enjoy that one. Oh, just having a bit of fun, that's all. It's so rare I have any visitors. I had to prepare a special surprise. Surprise? You nearly scared the poor child out of his robes. Well, yes, perhaps a bit too surprising. It has been a while. I did finally enjoy getting to meet someone down here. I suppose it has been a while. Red's grown quite a bit since you took him in. He has, and I believe he's finally ready for some of the lessons you and the others can teach him. You know, interesting you should say that. It was quite strange seeing him down here, especially with that gaudy door that you put up just to make sure no lemurs wandered in here. Especially with all those locks you put on it, and the bolts, and the chains, and the everything else. It's almost as if someone left that door unlocked on purpose. Now, whoever would do such a thing as that? Who indeed, who indeed? So it was in the tales of the Ruby Grimoire that Red the Lemur would come to know of its magics, and that his Master Scarlet would give him permission to study under the Master Crimson, and that he would become one step closer to his own masterhood. For you see, magic is integral to Ruby, to exploring, to expressing ourselves in code beyond what's possible in many languages. The beauty of programming in Ruby is that freedom, that we have to do just that, and that the very experimentation can and sometimes does become part of the language itself. But there was a cost mentioned, and that cost can indeed be very high. It does take a lot of discretion and great wisdom to handle such magic in production, and often the simplest code is best, and that's a special type of magic in and of itself, but that's a lesson for another day. So to wrap up, it has been fun. This talk was all custom illustrated by myself with about 12 lemurs, 62 illustrations, 85 hours, 156 slides, and a good deal of whimsy. 160 slides, I added a few, never mind. So, now for the scary part, because you thought this was a very heartwarming lesson then. Oh, no, I'm not a heartwarming fellow. Because it's real. Oh, yes, it is definitely real. And we'll ignore my affinity for two-letter gem names, most of which are indeed me doing bad things to Ruby. Amusingly, some of those bad things have and will end up in Ruby itself, like numbered arguments and placeholders and enhanced destructuring and pattern matching. You know, I'd still be quite fond of a berry function, but we'll endeavor nonetheless. So if you wish to find out more about me and the lemurs in the next adventures, because I do fully intend to make more, you can follow me on these social networks. I'll also be posting slides, just examples more. And the scary part is that all this code is indeed live. So if you want to play with it and see if that does indeed work, oh yes, it does. And I have used some of it in production. So a talk like this doesn't exist without some help. And I do like to acknowledge the fact that there are all those who are willing to entertain my mad science experiments in Ruby. From those who review the arts and the stories, it takes a community, and Ruby is one of the best I know, so really respect that and everything that you get out of this. I mean, you may have noticed a few foxes that might have been hiding as well, and that's because my first Ruby book was written by a certain lucky stiff. And as you can see, its influences the way I write and teach code a lot today. Ruby needs more whimsy and more fun, so don't be afraid to submit your own wild talks, to go on your own grand adventures, to tell a magnificent story, and to make us all imagine and believe a little bit again, because the world needs a little bit more whimsy. And thank you, it's been a fun time, it's been a trip.